To discuss related problems, the concept of errors and approximations. Now, this is one question. The length of the simple pendulum is decreased by 3%, and the percentage error in the time period of the simple pendulum. So here, the length of the simple pendulum is decreased by 3%, which means the percentage change in the length of the simple pendulum that equals to 3, which means we have to write delta L by L into 100 equals to 3. Then what is the percentage error in the time period, which means we have to calculate delta T by T into 100. For that we need a formula of the simple pendulum, which is the relation between the time period and length of the simple pendulum. So here the time period of the simple pendulum T equals to T pi into under root of L by G. Now take differentials. Take differentials. That is delta T equals to 2 pi by root G is constant. The derivative of root L is 1 by 2 root L into delta L. But we have to calculate what? Delta T by T into 100. That equals to, what is delta T? 2 pi by root G into 1 by 2 root L into delta L divided by T. This is the value of delta T divided by T. What is T? 2 pi into under root L by under root G into 100. Here also we should write into 100. So therefore delta T by T into 100, that is equals to, here 2 pi get cancelled, 1 by 2. Next root G get cancelled. This root L in the denominator, this root L is also in denominator, that equals to denominator L. Numerator delta L there, that into 100. So the percentage change in the time period of the simple pendulum, that equals to 1 by 2 times the percentage change in the length of the simple pendulum. So without doing this also, directly we can also write the formula. Here, what is the power of the L? Root 1 by 2. That becomes as a coefficient here in any type of problems. So that equals to 1 by 2 into, what is the value of delta L by L into 100 is, the length of the simple pendulum is decreased by 3%, which means percentage decrease in the length of the simple pendulum, that equals to 3. So 3 by 2, which means what? 1.5. So if length of the simple pendulum decreases, automatically, here we should take minus, then automatically the time period of the simple pendulum is also decreases by the 1.5%. This is the answer to this question. Now coming to the second problem, the radius of a sphere is raised from 10 centimeters to 10.02 centimeters. Then the approximate change in its volume is, here they give the radius equals to 10 centimeters, that is increased to 10.02 centimeters. So the increase in the radius is 10.02 minus 10, that equals to 0.02 centimeters. Then what is the approximate change in its volume? If V is the volume of the sphere, what is delta V they asking? So for that we need a formula between the volume of the sphere and the radius of the sphere. So the volume of the sphere equals to 4 by 3 pi r cube. So we want to calculate delta V. Take differentials on both sides. So delta V equals to 4 by 3 pi is constant. The derivative of r cube is 3r square. Write the differentials of r, delta r. So delta V equals to this 3 get cancels. 4 pi r square into delta r. So delta V equals to 4 pi. Radius equals to 10 centimeters. That is 10 square. Into delta r is 0.02 centimeters. So delta V that equals to 4 pi into 10 square, 100 into 0.02 becomes 2. So therefore delta V equals to 8 pi cubic centimeters. So here the radius is increasing, so that the volume is also increased by 8 pi cubic centimeters. So 8 pi cubic centimeters is the right answer to this question. Coming to another problem, a circular plate expands when heated from radius increases from 5 cm to 5.06 cm. Then the approximate increase in its area. So here initially the radius is 5 cm. After heating, the radius increases to 5.06. So the change in the radius is nothing but 5.06 minus 5, that equals to 0.06 cm. This is the increase in the radius of the plate. So what we have to calculate the approximate increase in its area. If A is the area, then we have to calculate the delta A. So that we need a formula between A and radius of the plate. So the plate which is in the form of a circular, so its area of the circular plate becomes area equals to pi r square. So we have to calculate delta A, so that you can take the differentials on both sides. Pi is constant. So the derivative of r square is 2r into delta r. So substitute the values. 2 pi. What is the radius? 5 centimeters. What is the delta r? 0.06. By substituting these values, it becomes 5 to the 10. Multiply with 10 becomes 0.6 pi square centimeters. So this much area is increases by increasing its radius of 5 centimeter to 5.06 centimeters. So this is a solution. Now coming to another problem. In measuring the vertical angle of a sector of a circle, radius equals to 30 centimeters and an error of 1 degree is made. That is the vertical angle. So that is delta t equals to 1 degree is made. Error in angle. Delta theta equals to 1 degree. What is the error in the area of the sector? Delta A value we have to calculate. So what is the formula between area of the sector and radius of the sector equals to half r square theta. Here theta that should be you can take in radians. Theta in only radians. So here that equals to 1 degree, that equals to pi by 180 radians. So that delta A equals to half r square delta theta. So delta A equals to half. What is r square, which means 30 into 30. What is delta theta? Pi by 180. So that delta A equals to 36 that 180. 6 to 5 that. So 5 by 2 into pi. So delta A equals to 5 by 2 is 2.5 square centimeters. So what is the error in its area of the sector equals to 2.5 by square centimeters. That is option 1 is the right answer to this question. Now coming to another problem. If there is an error of 0.05 centimeters in the measurement of the side of the 2 centimeter cube, then what is the relative error in the volume of the cube is? So here the side of the cube, let A be the side, the error in the side is 0.05 centimeters. If the side equals to 2 centimeters, then what is the relative error? If V is the volume, relative error is delta V, we have to calculate. So that we need a formula between the volume of the cube and the side of the cube. Everyone know the volume of the cube equals to its side cube, A cube. Now take differentials on both sides. Delta V equals to Derivative of a cube is 3a square into delta a. So delta v that equals to 3 into a square, that is side square, 2 square into delta a equals to, they gave 0.05. So delta v that equals to 2 square 4, 4 3 is 12, 12 5 is 16. It becomes 0.6. Yes, coming to the last problem. If there is an error of 0.05 centimeters in the measurement of the side of a 2 centimeter cube, then the relative error in the volume of the cube is. So, error in the side, let A be the side, this error in the side is 0.05 centimeters.